Hello, can you hear me? Hello, can you hear me? Hello? Can you guys hear me? I want to know so that we can start.
Yes, we can hear you.
Yeah, good. All right. Let's begin. Let me share my screen. This week, as you can see from my announcement for the week, we're now entering a new chapter, which is chapter 8 on confidence intervals. And you have one assignment, only one assignment, which is homework 8. And it is not due this week. Actually, it is due, I believe, next week. Yeah, so it's November 10, that means next week. And of course, you know that you can access this assignment by going to the models and then scrolling down all the way to the week. This topic lasts from week 11 to week 12. And it's called confidence interval. Yeah. So let us begin. Now, what is confidence interval anyway? A confidence interval simply means an interval that gives an estimated range of values that will likely include an unknown population parameter. That means the population parameter we're trying to estimate. And this range of values, the estimated range is calculated from a given data set of the sample data. So we are trying to estimate the range of value that will contain the population parameter. And when I say population parameter, I'm talking about the population mean. You can see the symbols on the screen. Okay. The population mean, the population standard deviation, and the population proportion. So we're trying to estimate this using the sample data that we are given. Now, let's look at some key concepts that will help you to understand this topic very well. Let's start with this point estimate. Point estimate refers to a single numerical value estimate of a population parameter. Usually, in fact, in statistics, the best point estimate of the population mean, for example, is the sample mean. Now, I'll give you a look. I'll explain with more examples. For example, if you look at the screen, you have that it says here, a local bus driver may claim that the average price of gasoline in 2022 was $3.67. See, this is one number. One number, that's why I call it point estimate. Our Ford CEO can say that the company produced on average 200,000 cars in 2013. Again, one number again, one number. So we call it point estimate. This is one you are familiar with. However, the one we are interested in tonight is the interval estimate, which means it tells us the range of values that can be used to estimate the population parameter. For example, the same bus driver might claim that the average price of gasoline in 2022 is between $3.50 to $4.50 per gallon. This one around, we're talking about two numbers, two values, the lower value and the upper value. So two of them. That is a good example of an interval estimate. Again, Ford CEO, the same Ford CEO can say that the company produced on average 190,000 to 250,000 cars in 2013. Again, two numbers, the lower value and the upper value. So this is the type of interval we are looking at in this topic, confidence interval. Now, the confidence, we measure your confidence by looking at your confidence level. The confidence level simply means the likelihood that the true population parameter, for example, the mean, lies within the range specified by this confidence interval. Usually, the confidence level, we normally express them as a percentage. The three most common confidence level, the most popular that we use in statistics are 90% confidence level, 95% confidence level, and 99% confidence level. Now, another concept we need to know is the critical value. So usually call it the number at the borderline. Before I explain the critical value, I want to make a flashback to the confidence level again. If you're 90% confidence, that means your chance of being wrong is 10%. If you're 95% confidence, that means your chance of being wrong is 5%. And if you're 99% confidence, in this case, your chance of being wrong is 1%. Pharmaceutical industries use this one. They're very, because you gotta make sure that you are 99% sure that the medication is doing what it is claimed to that it can do. What it is claimed that it will do. Otherwise, you're gonna face a lot of lawsuits, that can bankrupt the company. So now, critical value is the number on the borderline separating the sample statistics that are likely to occur and those that are unlikely to occur. Now, basically, it is, let me put it this way. If you remember, I said that if you're 90% confidence, then the chance of being wrong is 10%. That 10%, we can use it as the chance of being wrong, right? So you can use it to estimate the critical value. We call it the alpha, the probability of committing what we call type 1 error. We're going to meet that again, maybe when we start discussing test or hypothesis. Now, let's see how to estimate critical value. I'm going to make this to be 18. Okay. It says here, find the critical value. Find the critical alpha and the critical values using the information on the table below. Then complete the table. Now, what does this mean? It said they give you the confidence level and they ask you to find the alpha and then the critical value. The alpha, if you're 90% confident, your chance of being wrong is 10%, which means that alpha is 0.10. If you're 95% confidence, your chance of being wrong is 5%, which means that your alpha is 0.05. If you're 99% confident, your chance of being wrong is 1%, which means that your alpha is 0.01. And if you're 98% confidence, your chance of being wrong is 2%, which makes the alpha 0.02. Now, let us calculate the critical values. There are other methods we can use to calculate the critical value, but for confidence interval, I have this shortcut formula. Can use this shortcut formula to find it. Say Z alpha over 2. Why alpha over 2? Because it's two sides. Remember, the lower side and the upper side. Lower interval, upper interval. So it's alpha over 2. And because percentage is over 100, now we're talking about two sides. So you're gonna be, that's why I have P over 200. 100, percent. Now, let's apply this formula to find the critical value. Okay. Now look at the first one. It says 90%. That's gonna be equal to, I'm gonna make this hundreds. 18. So you're gonna be hundreds. Sorry, P for 90%. The critical value will be P represents the percentage. That means 90 over 200. Okay. 90 over 200. We can now look at our calculator. 90. Where is our calculator? Okay, let me find it. Okay. 90 over 200. Our calculator is right here. Okay, got it right here. You got 90 divided by 200. Okay. So you have 0.45, which is 0.45. 0.4500. Now we look for this value on the table of normal distribution. Remember I mentioned that you should print it. 0.45. Two numbers are closest to it. I have this one, which is 0.4495. And the next one will be this one here. And because I didn't see the 0.45 exactly, so I'm going to choose one that are closer to it. Now let's examine these two numbers. 4495. Let's see how far it is away from it. Okay. We got 4500. We got 4500 minus 4495. This is 5 points away. Okay, let's check the other one. The other number is 4505. Okay, 4505 minus 4500 is 5 points. So they are equally close. Both of them are 5 points away from 4500. So when they are equally close to the number, what you're gonna do is to choose the larger of the two numbers, which is this one here. Then flow it to the left. 1.65. So 1.65 is a critical value. 1.65. 1.65. And that becomes our critical value here, 1.65. Is there any question to this? Any question? Okay. So no question then. In that case, we can try another one until we get the rest of them. Now, the other one says for 95% confidence level. So we can get the critical value following the same method. I'm going to copy this formula. Okay. And place it right here. So you're going to be 95 over 200. 95 over 200. Okay. Now we can look at the calculator. Okay, clear this 95 by 200 is 0.475. 0.475. Okay, 0.475. Okay, which will give us 0.475. Look for this on the table of normal distribution, 0.4750. Well, okay, this time we're lucky. We find exactly number that represent 0.4750. See right here. Now you follow it to the left. Okay, you follow it to the left. 1.9. You follow it up. 6. 1.96. And that becomes the critical value. 1.96. So we're gonna put right here. 1.96. Okay. Now, to find the other one, because the question says find the critical alpha and the critical values using the information on the table below, then complete the table. So we have already found the critical alpha. We're looking for the critical value itself. So for 99, I'm gonna paste this again here and do 99 over 200. Okay. Now let's go and get 99 by 200. 99 by 200. 99 by 200. 0.4950. 0.495. 0.495. Okay. I make it 0 because the numbers in the table are 4 digits. 0.4950. Let's look for it. If you don't see it, we choose the one that is closest. 4950. I say 4959. This won't work. I say 4949 and 4951. Both of them are equally close. This one is 1 point away. This one is also 1 point away. So when they're like that, like I said, like I did in the previous example, choose the biggest one, which is the bigger one, the bigger of the two, which is this one right here, 4951. Follow to the left, 2.5, and follow up, 8. It's going to be 2.58. 2.58. That is the critical value, 2.58. Okay. Right. So now that is how to do it. So I will leave you to do. I mean, you can do this number 98%. You can find the critical value for the confidence level 98% as a practice by yourself. For your practice. Let's move on to the next step. Since this is about finding critical value, so I'm not going to waste your time here. So we just did it. Now let's look at how to compute the confidence interval. We're looking at first case 1, which is confidence interval for mean, where the population standard deviation is known and the sample size is large. That means n greater than or equal to 30. Now we say that statistically, the sample size is large if it's selected randomly, it is randomized properly, and if it is equal to or greater than 30, we say that it is a large sample. So the steps for calculating confidence interval for large sample where the population standard deviation is known. First step is to find the critical value. So I just showed you a few minutes ago how to find the critical value for confidence interval. Then next is to find the error margin, E, using the formula E equals to Z alpha over 2, which is the critical value, then times the standard deviation over the square root of n. Once you get the error, then on the left side, you subtract the error from this sample mean. And the right side, you add the error to the sample mean. And that will give you the two intervals, the lower interval and upper interval. Then, of course, you then conclude. Okay? Okay, let's try this example here. Okay? It says here that a sample reading scores. Let me make it 18. A sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the 95% confidence interval of the mean reading scores of all fifth graders. B, find the 99% confidence interval of the mean reading scores of all fifth graders. So let's start with A. First of all, let's write down our summary statistics. Say that sample size, a sample of reading scores of 35 fifth graders. That means N equals 35. 5 of them were selected. Has a mean of 82. Now I can't get the character from sample mean, so I'm gonna get it from the other workbook. X bar is 82. Okay, I'm gonna insert sample mean of 82. Okay, sample mean equal 82. Okay, I'll make this to be 20. So I'm gonna copy this. Okay, and go and paste it in the memo book. 82. Okay, I'll make this sample size N. Okay. Now, then the population, you see that the standard deviation of the population is 15. So you got delta. Okay. You can get the character from insert symbol. This is standard deviation equals 15. So you change sign. I'm going to go back to it. The standard deviation of the population is 15. And they say find 95% confidence interval. So let's use to find the critical value, which is Z alpha over 2. Z alpha over 2 for 95%. Alpha over 2. We calculated it. We did the calculation a few minutes ago. For the confidence level of 95%, this critical value would be, let's go to the table and pick it up. Right here. For 95% is 1.96. Okay, 1.96. 0.96. Now let us calculate the error margin. Okay. To calculate the error margin, I'll have to take you to the other workbook. But first of all, let me write down these values we have. We got we have sample size N equals 35. X bar sample mean is 82. Standard deviation is 15. Z alpha over 2, what's critical value is 1.96. So let's go and plug this into the formula for error and get our error margin. This is a formula for error right here. So I'm going to copy this and paste it there so we can get our error margin. Before I can get go there, I'm gonna go down a little bit. Okay, that's the formula right here. So we're gonna use it to find the error. So taking you to the other workbook, so where we can easily use the formula. We got this. Okay, equals critical value. Our critical value is 1.96 times. Okay. We got standard deviation over the square root of N. 15. We have a 15 as standard deviation. Then N is 35 fifth graders, right? And it says square root of that. See, square root of N. And make it a little bit bigger. Okay. The square root of N, which is 35. Okay. I'm gonna make this in unbold it. Okay. Now equal. So let's go and plug this in the calculator. Error equals 1.96 times 15 plus square root of 35. Let's go and put it on the calculator and get our error margin. Once you get our error margin, we're almost done with the problem. So you got 1.96 times 15 over square root of 5. 4.969, basically 4.97. 4.97. Okay, we can put in 4.97. Gonna copy this. Got our error. We're almost done. Once you get the error, the problem is as good as solved. Take it to the memo book and paste it there. Paste it from here. So we get our error as that. Okay. So that's now we're looking for the 95% confidence interval. Okay. So we have that the 95% confidence interval. Okay. I'm gonna make it make it bold and bold. Okay, is given by this formula. Remember the formula we have over there: x bar minus error less than the mean less than the s bar plus error. So that's the formula we're gonna use. And our s bar is 82. So you got 82 minus the error. And our error is 4.97. So you're gonna get this less than symbol. Right here, less than mean. Okay, less than. Okay, we have that means on this side. So once you get the error margin, subtract it on the left side and add it on the right side. 82 plus error, which is 4.97. Okay. 4.97. So you have I'm gonna write this down. Okay, 82 minus 4.97. Okay. Going back to the calculator. Okay. 82 minus 4.97. 77.03. Let's go and write it down. That side. They got 77.03. Oh, excuse me, sorry. 0.02 then less than, I'm gonna copy this side. Less than the mean, less than on this side, we add. So subtraction, like go there, add. Put the changes to add. Got 86.97. 86.97. 86.97. So we are trying to estimate this mean using these values. So now, once you get this is a confidence interval, it means that it is between 77.03 and 86.97. That's the mean, the population mean. Now when you finish it, to get full credits, you must interpret your work. Interpretation. We are now because this is the 95% confidence interval. So you gotta say 95%. We are 95% confident that the average. Now, you are trying to estimate the average reading score. Remember, the question says a sample reading score for 35 fifth graders has a mean of 82. So this 82 is only for 35 fifth graders. And you're trying to use it to estimate the population mean for the entire fifth graders. So you say find the 95% confidence interval of the mean reading score for all fifth graders. So that means that when you're interpreting it, you must put the word average or mean. So that we are 95% confident that the average, this is the average reading scores of all fifth graders. The average reading scores of all fifth graders. Okay. That the average reading scores. Okay. Now the average reading scores of all fifth graders. Of all fifth graders lies between 77.03 to 86.97. So that's the interpretation. That will give you the full credit. Any question on this one? Any question? Good. Now, since there's no question, I will continue. Now I'm going to show you an easy way to do this. Instead of going all the, just an easy, and that's we will using Excel. So let's go and put some of these things in Excel, and then I'll show you how to get it right away. So you go to Excel, an easy way. I put the values that we need to use right here. Okay. Make it 14. Okay. Now sample size for this one is 35. Sample mean S bar is 82. Population standard deviation is 15. Confidence level. For this one, the confidence level is 95. Okay. Say 95. Which means that the confidence level for this one will be 95. Okay. Let me see it better. Where I think I can see it. Give me 1 minute. So the confidence level, I'm gonna make this. I don't know if you can see it now. I'll try this. Okay, try it again. So the confidence level for us here is 95%. Now, so I'm gonna go there and put 95%. For 95% is chance of being wrong is 1%. But if you change 95% to decimal, I give you the 1.95. So 0.95. Okay. All right. Next thing we need is the error, to calculate the error. Remember the error is I'm gonna paste the formula here so you can see the formula as we do it. That's the error margin right here. Okay. I can paste it here so you can see it. In Excel. Let me paste it here. Control V. You can see the error margin. So I'm gonna move it right here. So that's the formula right here. That's the formula we use for calculating the error margin. So that means the error equals now because we're using Excel, we don't need this. Okay. I'm gonna remove it as a matter of fact. Equals, just type this confidence.num, confidence. See, it comes out. Double click. Now for the alpha, use 1 minus this confidence level. So 1 minus, then click on the confidence level. Comma. For the standard deviation, click on the 15, comma. For the sample size, you click on 35. Close it with closing parentheses. Once you did it this way, you can just press the enter key to give you the 4.96, which is, if you round it up to to decimal places, give you 4.97, which is the same thing that we got here. See, confidence level, this is the error is 4.97. See, now once you get your error, you can now get your interval equals that means mean minus the error. I'll give us the interval. And upper interval equals mean plus the error, which is this one here. See, we have our confidence intervals. And again, we can interpret it. You can even do everything here. You can interpret it and can put a text box here. So you can interpret it. Okay. You can see right here, interpretation. Okay. The same interpretation we have, we can just copy it and paste it here because make it easy for us. We are 95% confident that the average reading scores lies between the amount we stated. Okay, and paste it right there. Okay, let's save it. So that the average reading scores lie between, make it a little bit bigger, make it 16 as a matter of fact. The interpretation right here. See? Now, since I've shown you how to do it from I've shown you how to do it with what do you call it? Formula. And I'm also showing you how to do it Excel if you have smart statistics. We came to the same answer. And we look at, if you look at our answer for lower interval is 7.03. And when you go to Excel, you will see that it is some 7.03. Everything is the same. Now, suppose you want to do it for part B of the question says, find the 99% confidence interval for the mean reading scores. So now, in this case, we can just use a step to complete it since well, we did it now. One good thing about Excel is that when you do once you do the first calculation, you can use it to populate. You can copy the formulas and do the next calculation. So let me just copy it from here. Okay. And paste it here. Okay. This one is for 95% confidence level, 95% level. Okay. And this one will be for 99% level. So all we have to do now is to just change the confidence level. Okay. Confidence level, and that will give us our answer. So for this one, it says find the 99% confidence. So that means we can just go to that Excel and change this to 0.99. I want you to watch these two numbers, this one, as I click outside. See, it will calculate it. See. So now you can also interpret this. Okay, how do we interpret it? Same process. So I can put another text box here so that we can interpret it properly. So you have this. Okay. I interpret it right here. Okay, no, sorry, a mistake. This text box is right here. Okay, interpretation. It's something we just change the numbers, that's all. We are 99% confidence, this time around 99% confidence. Okay. 99, because we changed it to 99. That the average reading score is right between 75.47 to 88.53. This is new for you want 88.53. Okay, and that's the interpretation now. Any question on this? Any question? Good. Good. At this point, we're ready to do another example. Here, in this case, they didn't give us the summary statistics. They give us raw data. Okay, it's from here. And they say a random sample of the number of farms in various states are given as follows. So give numbers. Number of farms in thousands. That means this is 47,000 farms, 95,000 farms, and so on. He said, I'm going to remove this. I'm going to remove this one. He said, estimate the mean number of farms per state with 90% confidence. That means he's asking you to find 90% confidence interval for the average number of farms per state. First is since they didn't give us this type, where they give us the statistics, they tell us the N and they tell us the S bar. And in this case, they give us the raw data. So that means you have to estimate the mean by calculate the mean by yourself, calculate the standard deviation by yourself, and then calculate the error, and then you can get the other information. But the good news is that you can just Excel can do all that for us. Okay. So we have it in this form. First need to put this number in Excel, and I did. You can see them here. See it right there. 47 all the way to the last one, which is 50. And you can see that from your question that the last number there is 50. Okay. So now you can now use it to calculate the confidence interval. Okay. Now, first thing is numbers are in. Now, let's go to get the confidence level interval. Click on data. Okay. Make sure I've seen this. Okay. So please click on data and first, and then choose data analysis. Double click on it to bring us and then you look at this descriptive statistics. Okay. Yep. You click on that. Click OK. Now it will give you this dialog box. You see input range. Click on this and then to the input range. Highlight all the numbers. That give you the input range. Here. Now by columns, of course, and there's no label. Output range. Output means where you want it to be, where you want the answers to be. I want it to be placed here. Okay. Now the then you click on summary statistics. Then for confidence, click on it because this time around we're looking for the 90% confidence level. Say 90% confidence level. 90%. That's what I'm looking for now. And so to get that, we change that to 90%. Change this to 90%. Okay. Oh, excuse me. Change it to 90%. What is the Excel? Okay. Now, next is to change to 90%. And then that's it. Click OK. See, you give all the summary statistics. You can see from here. It places it where I want it to place it. I'm gonna make this a little bit bigger. You can see that it's basically did everything for us. Okay. Confidence level. Okay. So this is your critical, the error margin right here. Error margin right here for this. See, 90% error margin. Now you can now get the upper and lower interval. Lower interval. The upper interval. So this is an error right there. So I'm gonna make this bigger, make it 16. Okay. Now we can now get our confidence interval, which is this is the mean right here. 43.45. So the lower interval equals 43.45 minus the error of 9 points. This see 9.531. That'll give us the lower interval. And upper interval equals the mean plus 9.53 52.98. Okay. Let's see. Okay, now we can now put the lower end, put the answers here. Let me copy it from there. I can put it right there. You know. So we can say it. Anyway, we can just conclude it here. Let me just put the text box. Okay, put the text box. So we can conclude it under interpretation. I think I wrote it down somewhere. We can say, remember that this is about number of, this is, excuse me, sorry. This is about the number of farms, a random sample of a number of farms in thousands in various states. So we can then say that we can say, make it you can make it 18. 18. We can say with 90% confidence that each state has, on average, between 33.92 92 to 52.98 thousand farms. Yeah. That's how I interpret it. Now, any question on this? Yeah, good. There's no question. Okay, now we can then move on to next stage, which will be calculating the minimum sample size. Okay. Now, to find the minimum sample size, we make use of this formula you are seeing on the screen. And equals Z alpha over 2 times standard deviation over error raised to the power 2. Now let's apply this to at least 2 questions on that. Let us apply this. Okay. It says here that it is desired to estimate the mean number of chocolate chips, the cookies for a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence to use alpha? So use delta and the population standard deviation to be 10.1 chips. So let's get our summary statistics first. Now, they want to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? So let's find the Z alpha over 2. So we got Z, I know this in 18. Z alpha over 2. Alpha over 2 and the critical value equals. Now, if I refer you to what we did earlier today, I see here, but we did not calculate the critical value for 98%. So we can just use this formula to do it. Let me get the formula again. Is P over 200. Okay. So we're going to use it to find the sample size. Okay. So, oh, my mistake. The alpha, yes, we have it. Okay. Critical value is pi over 200. That means P For this one, it said 98%. It's going to be 98 by 200. Remember, this is just a shortcut method. 98 by 200. Okay. Now, if the critical value is given, you don't have to do this. You just put the alpha over 2. But in this case, it's not given. So 98 by 200. We got 98 divided by 200. 0.49, 2.49. Okay. 0.49. Let me put it this way. 0.49. Then for the table, we get 0.4900. 0.49. I have 0.49 from 0.4898 and 0.4901, then 0.4904. This is the closest. Okay. Pull it to the left, 2.3. And on Monday, 2.33. So 2.33. Okay, that means critical value is 2.33. 2.33. And with that, now we can get our other values. We are told that the standard deviation is 10.1 chips. So I'm going to copy it. 10.1 chips. And then we are also told that they want to estimate the true mean within the true mean number of chips within 2 chips. That means the error, it should be 2. Okay, error equals 2. Now let me write this down so we can go and plug it into the formula and get our answer for that. We'll have the delta is 10.1. Critical value Z alpha over 2 is 2.33. Error equals 2. So let's go and put it in so we can get our result. Go to our workbook, old workbook. I'm gonna come back here and copy the formula so you can start implementing it. Come over here, copy this, Control C. Now let's go and put it right there. Okay. So I'm going to do that. Minimum sample size N. So I'm going to clean these parts so that make sure you're seeing this. So you see Z alpha over 2, which we have already calculated here. And you can see that Z alpha over 2 is 2.33. So we have 2.33. So I'm going to put it right there. 2.33. 2.33 times standard deviation of 10.1 divided by error squared. Error is 2. So I'm going to square this, all of this. Okay. I'll put it, then put there. See, square it. Okay. So let's put it in. I'm gonna put this in calculator so we can get our final answer. And it equals 2.33 times 10.1 over 2 squared. Yeah. And we can go and get it from the calculator. Okay, have 2.33. Okay, we need to get one at the top first. Times 10.1 over 2. Okay, we have on this side, we got that squared 138.45 like that. 138.45, which is let me write it down in the workbook, which is 138. Oh, see, 138.45, which is one. You always go down to the next whole number. 139 cookies we need, or 139 samples. I'm gonna copy this. Group and paste it right here for this question. That's how you do it. Okay. Any question on this? Okay. No question. Good. So that's how you calculate this. Non-sample size. Sometimes they will give you you have the, like this one, there is a 95%, you have the critical value already. All we need to do is to plug the answer will show up. Let's do it. Okay. But 7 says a pizza shop owner wishes to find the say a pizza store owner should define the confidence interval for the true mean cost of a large plain pizza. Okay. You see that how large should the sample be if she wishes to be accurate within 10, 15 cents? That means if you're gonna make mistake, you're gonna just be, or maybe miscount 15 cents, you know. A previous study showed that the standard deviation of the population, and the standard deviation of the prices was 26 cents. So let's do it. First of all, let's get a critical value, Z alpha over 2, Z alpha over 2 equal. Now for this, for 95%, we calculated it before, we have it before. So we can just go and get 95%. It's like here, 1.96, see, for 95% is 1.96. So the critical value is 1.96. Go back there. Oops, good right here. 1.96 here. So that we have that, since we have it, but that's 1.96. So next one is the standard deviation. We have it here. Let me get a symbol here. The standard deviation equals, okay, 0.26. Now, this is for what it says, for the standard deviation, this is for the error of 15 cents, I mean, 0.15. So putting all this in the formula, we get, let me write them down. Z alpha over 2 is 1.96. Delta is 0.26. Error 0.15. So let's put this on the calculator. First of all, let's put it on the formula first, then you can put it in a calculator. Yeah. Got this. So we're gonna have Z alpha over 2. That means 1.96 times 0.26. What about error? What's the our error? Let me double check this. Okay. How large sample should we, okay. The error is 0.1, 15 cents. So I'm going to put that there, 15 cents. 0.15. So I'm going to clear this. But this one is about the pizza. Okay, how many pizza seeds we need? So let's put this in perspective. You have it on the formula. So let's do it. Okay, write it down. 1.96 times 0.26 over 2.15 squared. Yeah. Going to the calculator, we'll have, okay, 1.96 okay, times, okay, gonna go up, times 2.26, okay, times error of 0.15. You gotta square it. 1.54. 11.54. I mean, it equals always round up to the next whole number, which is 12 pizzas. Samples. Pizzas. Okay. Wait. First, memo book. So that's right there. So that's how to do it. Finding the minimum sample size. Any question on this last one with it? Any question? Okay, there's no question. Good. Now we can now move on to the next concept, which is confidence interval for the mean, where the sample size is small. Now, see, the standard deviation is the population's standard deviation is unknown, and the sample size is less than 30, which is small. Under this, we use what it calls the student t-distribution, because the sample size is small and we don't know the value of the population standard deviation. So in that case, we use that to the student t-distribution. The t-distribution is a table that is based on the sample size and degree of freedom. It was formulated by an Irish brewing employee named W.S. Gozet. So he was involved in researching a new method for manufacturing ale. Ale is a kind of alcohol. In those days, you know, scientists that work for companies are not allowed to publish their findings for the public, but Gozet wanted to do that. So the only way to publish it and that nobody knows about it, that nobody knows that it was him at that time, was to use a pseudonym that we call student. That's what they call a student t-distribution. So it's based on sample size and degree of freedom. And that degree of freedom is always given by n-1, where n is the sample size. So let's see how that table works. So let me show you the table of the student t-distribution table. It is right here. You can see right here, you can see student t-distribution. So for the one we are using, we are doing confidence interval. So we'll be using the one that have A with double prime. You can see A prime prime. That's one you're gonna use. That's A and this column here, and then the rest of this. Okay. Now, let's see. Let's show you how to use this table. Okay. You have this T, define T. See, we should now say find T alpha over 2 for 99% and for the following confidence levels. Okay. First one they give us is 95% confidence level. In this case, alpha, if you're 95% confident, that means your chance of being wrong is 5%. So your alpha is 5% or 0.05. Then sample size, you say is for the sample size of 22. Type 22 as the sample size. Degree of freedom is n minus 1. That means 22 minus 1 is 21. And critical value. This time we're using T alpha over 2, not Z. So all we have to do is to go to the table under the degree of freedom 1 and alpha 0.05 to find the critical value. So now, since we are using the alpha 0.0, so using alpha 0.0, 1 minute, let me open it. Alpha 0.05, that means 95%. And degree of freedom 21. I'm gonna go to the table now. We're using the one that have double prime, A prime prime. For 95%, we'll have it here, 0.05, which 22 degrees. You can see the DF. It's 22. Okay. So you have alpha, so 0.05. Okay. You can see 0.05. Okay, let's see. Let's see. 21, not 22. Look, we have here 1 minute. 21 with 0.05. So, like on the table, we have 21 degree of freedom. This is 0.05 right here. 21. This is 21 right there. See, this is right here. See, follow it to 21 and go up 0.05. So that'll be 2.080. 2.080. Let me write it down. 2.080. So you can do it right here. And go and write down here. 2.080 is the critical value. So that's how we do it. And let's do another one, like number 9 for 99%. That means your chance of being wrong is 1%. Put 0.01. That's your alpha. And n is 10. Type it 10. Degree of freedom is n minus 1. That means 10 minus 1, which is 9. So critical value. Let's do the critical value here. You look under 9 degree of freedom and alpha 0.01. Okay, 9 degree of freedom, alpha 0.01. So alpha 0.01 is right here. Here. With 9 degree of freedom, 9 degree of freedom is right here. Okay. 0.01 right there. With 9 degree of freedom. 3.250. 3.250. With 9 degree of freedom, 0.01. 3.250. Got 3.250. So that's how you use the table. That's how you get the critical value from the table. Now, having said that, we can now look at some of the requirements. I mean, with respect to when to use the Z or the T table. So here are requirements. When the population standard deviation delta is known, then Z alpha over 2 values, as the normal distribution table, can be used no matter what the sample size is, as long as the variable is normally distributed and the sample size is greater than or equal to 30. Then when the standard deviation is unknown, but the sample size is greater than 30 or equal to 30, then the sample standard deviation can be used in the formula, and Z alpha over 2 can be used, actually T alpha over 2. Okay. Now, when the standard deviation is unknown and sample size is less than 30, the sample standard deviation is used in the formula, and T alpha over 2 are used as long as the variable is approximately normally distributed. So that's explaining it basically. Okay. Now, let's look at this example here. It says a samples of 6 college wrestlers have an average weight of 276 pounds, with a standard deviation of 12 pounds. Find the 90% confidence interval for the two mean weights of all wrestlers. If the coach, if the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? So let's solve this, okay? I'm going to move it to next line so we can have enough room to solve this. Okay. Now the sample size is 6. 6 wrestlers we could say. And then we don't know the population standard deviation. So we use, because it's less than 30. And we don't know it. So we're going to use T distribution for this problem. So our S bar is 276 pounds and the standard deviation is 12 pounds. So we're gonna what is standard deviation right here? I'm gonna pick it from here. This is 12 pounds. Okay. Right here. The standard deviation is 12 pounds. So now the confidence level alpha, let me put it this way, says alpha. If you yeah, let me put it this way, degree of freedom df equals n minus 1 equals n minus 1 is 6 minus 1, which is 5. Now, this is not a standard division. This should be a sample standard division. So we're going to be using S. Okay, since we don't know the value of the population standard deviation. So let's get the critical value. In this case, we're using T alpha over 2 alpha over 2 equals, we get it from the table, under 5 and let's say our alpha is, let me put out my alpha first before I put that. My alpha is, it's a 90% confidence interval. So if you are 90% confidence, your chance of being wrong is 10%. So our alpha is 10% or 0.10. Okay, so T alpha over 2. We look under degree of freedom 5 and alpha 0.10, 0.10. So degree of freedom of 5. This is 0.1 right here. Look under degree of freedom of 0.5. See, 0.5 is right there. So it's gonna be 2.015. 2.015. Here, 2.015. Okay, I mean, adjust this. Okay. Now, so let's find the error margin. The error. So to find the error, I'm gonna get the formula from this other workbook. So the error will be error equals, this time around we are using T alpha over 2, T alpha over 2. Okay. T alpha over 2. And our alpha is, let me see, let me get it from here. Right here, alpha over 2 times, excuse me, times the standard deviation, which is sample standard deviation, over the square root of n, sample size, which is small n, which is, let me make it bigger, make it probably 18. So that we have it equals, and our T alpha over 2 from that side, right, is what you have on that side. T alpha over 2 is 2.015. Standard deviation S is 12. N is 6. So let's go and put it in so we can get our error. Okay. We got 2.015 times we have standard deviation of 12 over the square root of n. N is 6 raised to last. Okay. Which is 2.2. Oh, excuse me. Triple 6 not n 6 raised to last. So which means I'm gonna have, I'll write this down. 2.015 times 12 over root 6. Okay, that will give us the result. Let's go and put this on a calculator. We have 2.015 times 12 over square root of 6. 9.87. 9.87. Okay, let's go and put it in. $9.87. Copy this. And paste this right here. Now we have our error. So now once you have our error, the confidence interval is easy to calculate. So calculate it. You can now see that the 90% confidence interval is the 90% confidence interval. The 90% confidence interval is given by this formula. Formula is S bar minus error. Let me put it from here. Yeah, we used it before. I want to get it from that place. See, here, Control C, go all the way down. Here we are. S bar minus error. So an S bar is 276 pounds. 276 minus error of 9.87. Okay. Less than the mean. Okay, the mean less than same thing, but on this on the right side you add it. 276 plus 9.87, which means that our confidence interval is, I'm gonna do the calculation. Let me get this out first for. Okay, I'll push it right here. Now 276 pounds minus 9.87. Let's see what you got from there. On the calculator, we go and try it on the calculator. So you got 276 minus 9.87, 266.13, 266. Okay. Got 266.13. I'll put it right there. 266.13. Then on this side, you add it. So let's add it on that side. I'm going to go back to that place and just change it to plus. Okay. We change this to plus. Got 285. 285.87. 285.87. 285.87. so that the confidence interval, the 90% confidence interval lie between these two numbers. So it means how I will conclude here. This is how I read my conclusion here. We are 90% confident that the average weight of all wrestlers is between 266.13 pounds to 285.87 pounds. Now, that is how we got it. But the question have a second part which says, if the coach claimed that the average weight of wrestlers on the team was 310 pounds, would the claim be believable? The answer would be nope, it can't be believable. Why? Because 310 pounds, 310 pounds is not included in this interval of 266.13 to 285.87 pounds. It fell outside the range. The answer is no, because this 310 pounds falls or did not fall within the interval of 266 pounds to 285.87 pounds. They didn't fall within that interval. So that claim is not believable. Yeah. Now, any question on this? Look, guys, any question on this one? Okay. There's no question. Now, I want to show you how you can do this in Excel as well. And once you have this summary statistics, you can just put the what we are given. Sample size is 6. X bar is sample mean is 276. Sample standard deviation is 12. Okay. The confidence level is 90%. Now let's go and put this in Excel. You can see that our answer will be the same. But this time around, we're not using we are doing something, we are doing a small sample. So the answer will be different. So I'm just gonna copy this. Okay. All right. You know what? I'm gonna erase this. Move this. But with sample mean, sample size. I gotta make all this. Made them 14. So you can see that. Make it 16 even. Sample size. And here for this case, for this particular one example, you see how many wrestlers, 6 wrestlers were chosen. So the sample size will be 6. 6 wrestlers, so 6. Then out of which sample mean, X bar, sample mean, X bar, according to the equation, the sample mean of the 7 wrestlers, their average weight is 276 pounds. 276 pounds, and the standard deviation is, this is the sample standard deviation is 12 pounds. So you have 276 pounds. Okay. Sample standard deviation, sample standard deviation. Okay. I'm gonna so what again is I'm gonna look at this from the question. Sample standard deviation is 12 pounds. Okay, 12 pounds. Next is the let's see, confidence level. For this question, the confidence level was 90%. So I'm going to put 0.9 right there. Let's go and put 0.9 right there. So no point which represent 90%. So let's find the error this time around. Let's find the error. Okay. Let's find the error. The error margin. Okay. Now, this time around, we're going to be using confidence.t, not .num. Okay, since this is a t distribution. We're using confidence.t, not confidence.num. So let's do it. Equal confidence dot t. It pops out, double click on it. They say alpha. Okay. For that, we do 1 minus confidence level, comma. The next one is the standard deviation is 6, is 12, comma. And the sample size is 6. Then close it. And it will give us the 9.87. See, the same 9.87 we got before, we also got it on now. See, that's an error. And when we look at the one we got from the calculation, you can see that it is still 9.87, which is what we got here. Now, then we can then get the lower interval and upper interval. As we already know, for lower interval, you subtract x bar, which is the mean, minus the critical minus the error. Give me this 2260.13, which is exactly what I got here. Okay, what is it? See, I see that's 260.13. Okay, 260.13. Now let's add it, and you will see that we got the same result for addition. Equals x bar plus error of this 25.87. And you can see from that place. Let's see from here. 25.87. So that's how you do it. How you do it. Now, another example, they ask for that question where they give you in this form, they give you the numbers. All you have to do is find the mean using the Excel, find the standard deviation using Excel, and then get the whole thing. Let's do it. Let's do this one. That'll be our last example for tonight. And then we can now, next week, we look at confidence interval for proportion. Okay. It says here, the following data represent the sample number of home fires started by candles in the past several years. Actually, you can see that how many of them? 1, 2, 3, 4, 5, 6, 7 years. So 5,460 home fires started by candle in one of the years. And we say find 99% confidence interval for the true mean number of home fires started by candle each year. So first thing, of course, is to put the data sets in Excel. Let me write them down so we can put them in Excel. I have 5460 5900 6090 6310 7160 84 440 9930. So let's go and put this in Excel, and then we can go from there. Okay, I'm in Excel. I can go down a little bit and put numbers here. We got 54. Make sure I've seen this. We have 5460. I'm going to make this the whole of this column that we use, make them, and this one, make them to be 16. Okay, good. Next will be 5900. Next will be 6090. Next one will be 6310. And we got 717160. Eight 440. 9930. Okay. So 1, 2, 3, 4, 5, 6, 7. So we're gonna calculate the mean. Okay. We calculate the standard deviation. Sample standard deviation. And then we use them to find all this. Okay. 16. Okay, good. Now I'm gonna get all this. To find the mean, of course, I showed you how to do it with the Excel. Just put equal average. Highlight all this. Press the Enter key. What the mean? For the standard deviation, just do STDEV because the sample dot S pops out. Double click, highlight, or press the Enter key. So make all this to be since we look at our question. Okay, I want to look at the question here. I want to make them to be 2 decimal places. That'll be better for us. 2 decimal places, like that. So I'm going to highlight this. 2 decimal places. So good enough. So that's the mean and standard deviations. Now we can get our values. We got sample size n. And sample standard deviation. Sample mean. Okay. Yeah. Then what else? Alpha. We need confidence level. Okay. Sample size we have how many? 1, 2, 3, 4, 5, 6, 7 years. Okay. Then we have sample standard deviation. We got the as this right here. Enter it's there. And sample mean, we got it at this here. Then confidence level. You say, let me make sure again I have the correct confidence level. It says 99% confidence level. So we got this 0.99. So let's find the error margin. The error margin of error equals confidence dot T here. So we have for alpha, do 1 minus the confidence level, comma. The standard deviation is this, comma. Sample size is 7. Close it and enter key. 2256.4, that's the error. So that we have our lower interval, then upper interval, so for lower interval, just do mean minus that. Mean minus this, and then press the enter key to give me the answer right away. And for the upper interval, I just do I equals mean plus the error. Give us. So this is a interval, the confidence interval. So conclusion, interpretation of this, and put the shapes here and put the text box. So as a matter of fact, I have it written already because I taught this before. We can say with 90% confidence that in between, yeah, let's see, for here, between make it 18 as an interpretation. Okay. You can say that with confidence, with 99% confidence that on average between 4,780 actually 780 4,784.99 to 9,297.687 homes. Home pairs as started by candles each year. So that's basically how to do the confidence interval for the mean. I done two cases. Case one, where we have the large sample with the population standard deviation known. And then this case two, where the population standard deviation is not known and the sample size is small. Now, when we come back next week, we'll begin the confidence interval for proportion. Next week, we'll start that, or next week, we're going to cover that next week. Now, before we don't go here, let me check all your names for those of you who are here. While I do that, anybody have any question for me? That's 9, 10. Any question for me? Floyd. Okay. Coleman. Yeah, Coleman. Q. Any question for me? Harris. I got Harris. Marcus Graham. Got them. All right, since there's no question then, I'll let you guys go and I'll see you next week. Okay. Have a good night.